Now, we're going to do a little bit of work on solving equations. Most of what I'm going to show you here is stuff that we've already been doing when we've been answering problems in area and volume, and some of which we've already been doing when we've been filling into the equation of the line and finding the distance between 2 points and all of that sort of thing. But let's put some rules on it. So you have seen these types of questions before, but maybe you didn't fully understand why things were happening, like why when I move something from one side to the other, does it become a minus sign? So the first note that we want to take down here is it's a really important thing about equations. You can do anything you want to an equation in maths, so long as you do it to both sides of the equation. So you can do anything you want. I can multiply, I can add, I can divide, I can square, I can get the logarithm, and various other things. I can raise it to a power. You can do anything you want to an equation in maths. So long, this is really important, as you do it, you do the same thing to both sides of the equation. What do I mean? Well, let's look at an example with some basic numbers. We'd all agree that this is a true statement, that 3 is equal to 3. Okay, 3 equal to 3, that's not a mind-blowing statement at all. Everybody agrees with it, and that is an equation. Not a very interesting equation maybe, but it is. So what might I want to do to that equation? Well, what about if I added 5 to both sides of the equation? Would we agree that 3 plus 5 is equal to 3 plus 5? We would, because 8 is equal to 8. Okay, so I can do that. What about subtracting? I can subtract maybe 10 from both sides. I'm writing down in blue what I'm doing to both sides. So let's maybe separate this off. So this is what I'm doing, and I must do it to both sides of the equation. So if I subtract 10 from both sides, if I have 8 minus 10, is that equal to 8 minus 10? It seems nearly too simple to even write it down. Minus 2 is equal to minus 2. So you can see that what's happening is equality is preserved. So long as I do the same thing to both sides of the equation, I'm not changing anything. What about if I multiply it? Let's see what happens if I multiply my equation by 3. So if I've got a minus 2 times 3, is that equal to minus 2 times 3? It seems so obvious, right? Well, we get minus 6 equal to minus 6. Yes, they're equal to each other. I can raise them to a power. Okay, this is the little symbol for raising something to a power. What if I raise them to a power of, I want something I can do in my head, so I'm only going to raise them to a power of 2. So if I've got a minus 6 to the power of 2, is that equal to minus 6 to the power of 2? Well, it is, obviously. 36 is equal to 36. So you can see there, we can do anything we want to an equation so long as we do the same thing to both sides. That seems so obvious when we do it with numbers that it nearly feels pointless to write it down. What about if we have some variables in there? What about if I told you that x is equal to 3? Well, what that means is that exactly the same thing as I did to both sides before, I can do that here as well. If I add 5 to both sides, and I'm going to go a little bit more quickly now, then x plus 5 is equal to 3 plus 5. X plus 5 is equal to 8. If I subtract 10 from both sides, then x plus 5 take 10 is equal to 8 take 10. So we have x minus 5 is equal to minus 2. So you can see that we're getting more complicated equations now when we do this. Multiply by 3. I can say that 3 by, but I must do the whole side, okay? I can't just do 3 times x, it's 3 times x minus 5 is equal to 3 times minus 2. So I get 3x minus 15 is equal to minus 6. Raise it to a power of 2, and I can say that 3x minus 15 to a power of 2 is equal to minus 6 to a power of 2. Now I'll do the multiplication out here, but don't worry too much about it for the moment. This would be 9x squared minus 90x plus 255 is equal to 36. That's what we end up with. So we can see how complicated it starts to look using algebra, and usually we don't want to make something more complicated. What we actually use this for is we use these rules. So the point is that these rules are true. Is this true? Well, actually, we started by saying that x was equal to 3. So if I substitute in x equal to 3 here, I get 9 by 3 squared minus 90 by 3 plus 255. Will I get 36? You type that into your calculator. I don't have my calculator in front of me right now, but I encourage you to try it at home. You will get 36 equals 36. So I'd like you to try that and see that our equality is preserved. Let's write it down as a kind of a fancy statement. So equality is preserved so long as we do the same thing to both sides of the equation. Right, there's another note I want to write down. So the next important thing we want to say, 2, don't have to give it a number, is that everything in maths has an opposite. Let's list out some of them. So, for example, the opposite to addition is subtraction. The opposite to multiplication is division. The opposite to raising to a power of 2 is a square root. And we have more than that as well. So just a note on this notation, this means raising to a power of 2. So anything we can do to maths, anything we can do in maths, we can do the opposite of it. And these two facts, the first note, doing the same thing to both sides of an equation, and getting the opposite of a function, the opposite of something we've done in maths, allows us to solve equations. So when we are solving equations, when we are asked to solve equations, what we try to do, we try to simplify. We try to get x on its own on one side. So we're trying to undo what was done to x. Now I say x, but equations can use different variables. X is sort of our default. So what we do is we try to have our letters on the left of our equation. We We try to have our numbers on the right. And then we will always, our last step will be to divide, because we're undoing multiplication, across by the coefficient. This is something that we did in area and volume quite a lot to get x on its own. Let's look at some examples. Some basic examples to start with. So example 1. Solve for x. Change my pen. Solve for x. The first one is going to be very, very simple. X plus 7 equals 10. We'll build it up nice and slowly. 3x is equal to 12. Four x plus 2 is equal to 28. Let's change that. I will say, no, that's fine. We'll leave it like that. We can get fractions. What if we had x on both sides of the equation? 3x minus 6 is equal to x plus 8. Like that. Okay, so we'll start with these and we'll show how we're going to use our undoing method and manipulating both sides of the equation to get the answer. So for question 1, if I've got x plus 7 equal to 10, I want to undo what was done to x. So what will I do to both sides? Well, 7 was added to x, so the undoing is to subtract 7 from both sides, meaning that x plus 7 minus 7 is equal to 10 minus 7. And 7 take 7 is 0. They cancel each other out, giving me that x is equal to 10 take 7, x is equal to 3. Now that one was so simple you could have done it in your head without using the process, but I wanted to get us used to it. So the undoing here, this is what I did. I was undoing the 7 that was added to x. That's what we were doing. Part 2. I have 3x equal to 12. Well, what's happened to x here is that it's had a 3 multiplied by it. So to undo, I have to undo multiplying 3, and I divide by 3. And what we get is 3x divided by 3 equals 12 divided by 3. And 3 divided by 3 is 1. So they cancel as well. They cancel into each other, giving me 1x, or just x on its own, is equal to 4. X is equal to 4. Okay, I hope you can see how that works. Now, I'd like you to pause the video here for a second, and I want you to try some simple ones like that, just to make sure that you understand them yourselves. So try to solve x minus 3 equals negative 2 and 5x equal to 25. Again, you can probably do it in your head. So pause the video, try those, and then come back and I'll show the solutions. Now, the solution to this is that I must add 3. I must undo a minus 3. So I'm going to add 3 to both sides. I get x minus 3 plus 3 is equal to minus 2 plus 3, which means x is equal to 1. And here I must divide by 5. So 5x divided by 5 is just x, starting to skip steps now, and 25 divided by 5 is 5, so x is equal to 5. Right, let's look at part 3. Let's move my paper slightly. So part 3, we had 4x plus 2 is equal to 28. So this one's a little bit more complicated. And we need to undo what's done to x. So the first thing I'll undo is the plus 2. I'm going to subtract 2 from both sides. And we'll say that I've got 4x. I'm going to start just doing it in my head. 2 take 2 is 0. 28 take 2 is 26. And then I'm going to undo the 4 that's multiplied by x, dividing across by 4, and I get x is equal to 26 divided by 4, and that simplifies to x is equal to 13 over 2. You can leave it like that as a fraction, or x is equal to 6.5. 6.54. Either way of writing it is correct. Part 4, we had 3x minus 6 is equal to x plus 8. So again, what I want is all my letters on the left. So I'm going to undo the x that's added to this side by subtracting x from both sides. Subtract x from both sides. So we get 3x minus 6 is equal to x minus x plus 8. And what happens here is x take x gives me 0. So it's like it cancels. And when I simplify this, 3x take 1x is 2x. That's my like terms. Minus 6 is equal to 8. Now I've got this minus 6 to deal with. So I add 6 to both sides. And I get 2x is equal to 8 plus 6. 2x is equal to 14. Finally, I need to undo the 2 that's multiplied there. So I divide both sides by 2. And x is equal to 7. Now this is long and time consuming, so we start to take some shortcuts. So let's write down the shortcuts that we're going to start to see. Instead of writing down that we're adding to both sides or subtracting from both sides, we talk about moving something across the equals. So instead of adding or subtracting to both sides and writing it down, we move terms across the equal sign and change their sign. So if I look at part 3 again and use this process, so part 3, we had 3x minus 6 equals x plus 8. So rather than writing down that I'm subtracting x from both sides, I'm going to bring my x, we talk about bringing the x over here, and it's going to become a minus x when it's on that side. And at the same time, to save me time, I'm going to bring my negative 6 to this side, and it's going to become a plus 6. Again, you won't have to write down the arrows either. You'll find that you'll get used to this very quickly and you'll just start doing it. So I'll have 3x minus x on this side equals 8 plus 6 on this side. 2x is equal to 14. I still like to write down what I'm dividing across by because I find it stops me making a mistake, but you don't have to do that. We divide across by 2, and I'm not changing the sign because the opposite of multiplication is division, not minus. So x is equal to 7. And hopefully you feel that that's a lot quicker than writing down what we're doing to both sides of the equation. Okay, and again, I want you to pause the video now and I want you to try one of those yourselves. So you're going to try to solve 2x plus 12 equal to 4x minus 6. So pause the video and try that. Now, hopefully you got this working out. So my 4x is going to move over here and I'll have 2x minus 4x equal to my 12 is going to move over here, minus 12 minus 6. The plus 12 moves over and it changes sign as well. Simplify, minus 2x is equal to minus 18. And finally, divide. Now when we divide, we must divide by not just 2, but by negative 2. So we get x is 9. You can do this into your calculator if you're not sure, but a minus divided by a minus is a plus. So let's remind ourselves of that. A minus divided by a minus is a plus in our answer. So x is equal to 9. Okay, let's try a slightly harder example that involves some of the algebra that we did earlier, where we're multiplying out brackets. So this is example 2. Just making sure that's on the screen. Yeah. So we're being asked to solve for x. 5 bracket 2x minus 1 equals 2 bracket 6x minus 3 plus 4x minus 2. And there's going to be a follow-up with this as well. We're going to be asked to verify our solution. Verify your solution. So the first thing we're going to do before we even attempt to undo anything on both sides is we're going to multiply out the brackets. So we can't do much when there are brackets involved. Because they get in the way of everything we want to do. So I've got 5 by 2x, that's 10x, minus 1 by 5, that's a minus 5, equals 2 by 6x, that's 12x, 2 by minus 3 is minus 6, plus 4x, minus 2, and let's simplify as well. 10x minus 5, remember simplify means add like terms, so 12 plus 4 is 16, and minus 6 minus 2 is minus 8. Okay, so the first thing we did was we multiplied out the brackets. Next, this is what you're going to hear me say so much over the next couple of years. Letters left, numbers right. And of course, we must change the sign when we do that as well. My minus 5 is going to go over to this side, and my 16x is going to go over to this side. And when I make that movement, I must change the sign as well. So I will have 10x take 16x is equal to a plus 5, take 8. So 10x take 16x gives me a minus 6x equal to a minus 3. And then finally, I need to divide across by the coefficient, or dividing by a minus 6, because that's the full coefficient includes the sign. So x is minus 3 divided by minus 6. X is a half, or 0.5. Now, we're fairly happy with that. That's how we solve a bit more of a complicated equation. But there's a follow-up. Verify your solution. So verify means to show something is true. And verify in maths, if you're solving, means you sub in the value into the original equation. Always the original equation. Which means that I must show that if I have 5 times 5 bracket 2 times 0.5 minus 1, is that the same as 2 bracket 6 by 0.5 minus 3 plus 4 by 0.5 minus 2. Now, it is enough to just type each side into the calculator and show that you get the same thing. So I would like you to do that yourselves. Here we're going to have 0 on this side, and on this side we're also going to have 0. So type these into your calculator and show that this is true. Or do it in your head. Here I've got 2 by a half is 1, 1 minus 1 is 0, 5 by 0 is 0. 6 by a half is 3, 3 minus 3 is 0, 2 by 0 is 0. 4 by a half is 2, 2 minus 2 is 0. Okay, so hopefully you can see that. Now, I'm going to stop there for today. So this was quite long because we have a double class on Wednesdays. If there's something you don't understand, please let me know. I'm going to give you quite a bit of homework to do to practice with these. And tomorrow we might not do much more than just correcting that homework and feeling comfortable with these types of questions. Okay, thank you.